Good afternoon, everybody, and welcome to our webinar. Today, we're going to be talking about using financial aid modeling to optimize expenditures. And we're going to be talking about this today. My name is James Cousins, and I'm joined by John McMillan, and together we represent Vera by Rapid Insight. And so showing, just starting to poke through the itinerary for today and what today's presentation is going to look like. I'm going to share with you who we are, what we do as a company, but I'm going to keep that pretty high level because I want to be able to jump straight into some of the benefits and challenges of financial aid modeling. We're going to talk about different modeling techniques, and then John is going to show us a demonstration of actually applying one of the methods that we are going to discuss. So as we start to talk about who we are, I guess the underlying premise of what we represent is easy, affordable, and powerful analytics. So as a company, we're committed to making the sorts of insights that you can gather from data and the sorts of decisions that you can be informing with that data easier to come about, more affordable, so it's not going to cost you an arm and a leg to start to get at some of the important underlying revelations that may occur, and also, of course, to support you through this process to make it as powerful a process as possible. And so we help you do that through the platform that we offer, which is comprised of Vera Construct, Vera Predict, and Vera Bridge. And so each of these have specific purposes, but they work together to allow you to, here at the start of it, to gather your data from any source in which it might exist, to combine that seamlessly and without necessarily having a technical background. Once that data is together, the process of learning from it and having it explain to you or point out to you some of the really telling relationships between key characteristics and outcomes like financial aid as it pertains to enrollment, as an example today. That's possible through Vera Predict, our predictive modeling application. And then you can share those results and that data with anybody who might be interested on your team or in your organization or institution through Vera Bridge. And so they all come together seamlessly, and we're going to be getting a sense for that later on. But as I mentioned, I wanted to be able to jump straight into the content of today's presentation. And so, as we do talk about that, keep in mind that what does set us apart from the competition is that we are affordable, our products are quick to learn, easy to use, we are entirely transparent all along the way. There are no black boxes. Everything that our software accomplishes is entirely visible and customizable by you. And then, of course, you would have the ability to speak with myself or one of my colleagues on the support team for free and in unlimited fashion. Our training and support is a prime facet of what we offer, and we are very proud of it. And so, on to the actual topic matter here today. Financial aid modeling, what we refer to there, essentially is building predictive models looking at, in a lot of cases, enrollment management. So trying to bring on new students to filling your classes with a mind towards incorporating financial aid information. Those who are, I assume that everybody in the audience is pretty familiar with financial aid, either dealing with it directly or very heavily in a supporting role. When you accurately allocate financial aid, what that means is that the students that you're offering aid to, their need is being met. And so there are a lot of benefits to it. If you do incorporate financial aid into your modeling effort, it allows you to allocate that money to the students who are most likely to enroll, so that you're not offering money to students that have, I guess very simply, to students that aren't going to enroll. Because what that does is it ties you up. You aren't able to offer that financial aid to other students who need it until, of course, it's too late and you left money on the table. It does allow you to meet more need from among those who do enroll, meaning that you have a class that is more thoroughly supported and you're more fully meeting your institutional mission. You can increase your enrollment yield through this process, meaning that more of the people that are applying to your school and being admitted will actually arrive on campus come fall or spring or whichever term it is you're hoping to bring students on. And then I think that really coming to a head is the fact that this leads to more successful outcomes. So it's not just about filling seats, it's about actually helping those students through to succeed. And there are several ways that any institution will support their students. But I think in particular, financial aid and unmet need is a critical factor that correlates with student success. And so if you're doing that more effectively, if you're meeting more students' need, then you're also helping them to be more successful in the long run. So for today, we'll leave my side of things there because I wanted to share with you why it's valuable to approach this process. But my colleague, John McMillan, has been working with a lot of individuals recently this past season, especially to incorporate financial aid into enrollment modeling. So John, feel free to take it away.
Thank you, James. And thanks everyone for joining us. I should mention near the end here, we'll be saving plenty of time for questions. So as we go through this, if you have any questions on what we're discussing, what we're going to show later on in the demonstration, please feel free to type those in, and we'll save plenty of time at the end. But as James mentioned, there's a lot of benefits to financial aid modeling. So it really can provide a lot of useful resources, whether that's meeting your enrollment goals, meeting more need for students, and so on. But with any predictive modeling project, there are a lot of challenges that we need to address, and probably more so when we're talking about financial aid modeling. And so we'll take a look at a couple sort of common challenges, and then we'll kind of walk through some use cases, what we've seen some institutions do to avoid these challenges or to overcome them, I guess. And so first and foremost, what I've seen a lot of schools do in sort of that first roadblock they hit is that they have a data set that is including financial aid, looking at admitted applicants, and then seeing, based on how much money we offer to students, we would expect probably a higher increase in enrollment yield for those getting a larger financial aid package. And what we often find is the exact opposite. And so you'll see a relationship like you see here, where as scholarship aid increases, we see decreases in enrollment yield. And what that is telling us is that if we offer more money to students, we're going to see less of them enroll, which really isn't very intuitive and not really the underlying factor. So that's something that we'll look at and how we can address that today. Another issue that we face with financial aid modeling is that this is something that is constantly changing. We're seeing discount rates increasing year over year. We're seeing new awards, different awards, tuitions increasing. So it's something to when looking at historical data to keep in mind, and another challenge that we have to overcome. And then often those that are performing the analysis are not the ones that are maybe most knowledgeable when it comes to financial aid packaging. They may not even have access to the data itself. So that is another common challenge that we face, is that those that are building the models, maybe it's someone in institutional research, enrollment management, those that are working with the data are maybe not the ones that have all of the knowledge when it comes to the financial aid process. And just to name a few more, there are quite a few others. So things like requiring maybe more than 3 years, which is what our typical recommendation is when you're looking at enrollment modeling, is to include 3 years of historical data. You may have to go further back than that. There may be special circumstances to consider looking at athletes. Should we exclude them from these particular analysis? Things like that. And it isn't to say that these are things that we come across in any analysis that we're doing, but there are a lot of challenges here. And so today we'll talk about some of the different ways that we've seen some schools approach this and how we can overcome these. But looking back at those top three, so more money equals lower enrollment likelihood or lower yield. Awards and amounts are constantly changing. And often we're needing a financial aid expert in this process with us. And so this is really kind of the fun part of data science, at least for myself, sort of creative problem solving, thinking about ways to find this information in the data that we have. And so we need to be able to look into this, dissect it a little bit further, and look at different cohorts or groups of students differently. And so there are a number of ways that we can approach this. And for that first problem, more money equals lower enrollment likelihood, we'll actually walk through some examples. So we're going to talk about this here in the upcoming slides. But when it comes to awards and amounts constantly changing, that's something that we can address a few different ways. The most common way that we've seen is looking at financial aid as a percentage of tuition or need. So rather than looking at strictly the amount offered to students, we can keep it sort of on a consistent or level playing field if we're looking back at 3 historical years, by looking at how much of that need our tuition or our financial aid package covers. And then for needing a financial aid expert, when it comes to actually building out the data set, analyzing it, determining when or the point in time you're looking to be able to predict this outcome, that's really pretty simple. Just include them in the process. And that's something that we see a lot, is that those that are creating these analyses will be working sort of on an island. They'll be working in the data for weeks, maybe to develop these models. And then they come out with this great model, but those that aren't involved in the process aren't as inclined to incorporate it and actually drive their decision making. So assembling a team of those experts that you need, and those that are going to be actually providing these or using this information, is really key and really helpful in getting this project off the ground. And so let's talk about some of the problems that we've seen and some of the ways that some of our customer institutions have worked around those. One of those is, as we mentioned, we often see the inverse relationship that we would expect. Students that are offered more money seeing lower enrollment yield within those. And it's not necessarily because we're offering them more money, and very hopeful that it's not because we're offering them more money, but instead those students that we are offering more money to are those that are some of our, we're competing for maybe more heavily. They're getting more offers from other institutions. And so we need to be able to look at this slightly differently. And so one of the schools that I've worked with looked at binning students into similar groupings or similar bins based on different factors. That could be academic indicators like test scores or high school GPA. It could be based on their need, or it could be a combination of all of those things. And what this does is, looking back at that sort of relationship that we've seen, we see that as scholarship aid increases, we have a decrease in enrollment yield, but really the underlying factor is not the scholarship aid. So it's correlated negatively here, but it's not causing that decrease in enrollment. Instead, there are other aspects that are at play. And in this case, it could be their high school GPA. Those that are getting $10,000+ in offers are those that have a 3.5 or higher. And so those are the students that have maybe 10 of their offers from institutions that we're competing with. And so actually kind of shifting this and looking at specific points in the data, or specific bins of students in the data, can really shift this relationship and show us what we'd expect. As we increase scholarship aid, as we increase those offers, we see an increase in enrollment as well. And so being able to look at this, and within the analysis itself, being able to play with these different attributes, find the sort of underlying causes, control for those, and then build your models is pretty significant. And we'll actually today go through that example. But before we do that, I'll turn it back over to James to talk about some of the things that he's seen.
Thanks, John. And I also, as I go into my the example that I've been involved in, a couple of them, I did want to call back just really quickly to a point that John had made earlier in the presentation. The quote, which I'm sure several people have said it at various points of frustration in different projects, but this idea of assembling a team and involving them early and often, that is exactly what led to both of the solutions that that I've come across here that I'm about to present with you. And so it has a lot of positive aspects to it. I think the most important piece is that even if your specialty is not in the data analysis, working through these puzzles and trying to factor in financial aid, this requires has an opportunity for everyone to contribute, regardless of their actual skill set or background or involvement in the process. So these solutions were very collaborative. So identifying them, in this case, what was happening was there was a discretionary grant that was offered up to specific qualifying students, and anyone within that pool was eligible for this grant. It was not seeing the results that everybody expected when they set out about this. So they would assign the grants. There was, as would probably be expected, there were fewer dollars than there were eligible recipients, unfortunately. And so as they were going through, they had discovered that if you can first identify those individuals that are likely to yield or that display a higher affinity and still fall within the category that the grant was designed for, if it's a performance bracket or if it's an out of state or anything along these lines, you can have this grant accomplish the mission that it was designed for if you identify these likely to yield students and offer the grant to them. So a visual example to represent that process, there are two ways that ultimately this was approached, and you can probably guess which one came first, and you can probably guess which one they're still using today. So if you look at the top here, the random assignment, if you can offer an amount of money to a subset of your students, of your admits, then one approach, unfortunately, if you don't have any other reason to inform your decisions, then you might apply it randomly, and so you would end up, maybe assigning it to people all along the spectrum of likelihood to enroll. So on the far side here, you have those that, as it turned out, were least likely to enroll, and then on the left side, you have those that were most likely. So the random assignment might yield, and in this case, yielded 2 out of 5 acceptances, meaning that a lot of the dollars that were set aside couldn't actually go to work benefiting students. However, if you do look at the results and you identify the students that are likely to actually arrive, then you can actually inform that and increase the yield on that grant package. And so this is a real scenario. Somebody, a customer of ours, actually did double the yield on a grant just like this one. And it was a team effort and they had worked together, but this is just one of the ways that you can use predictive modeling as you're going through financial aid assignments. Now, if that doesn't apply to you, if that's not necessarily your circumstance, keep in mind there are other possibilities here. So the other option here is an offer based on expected response. And so this is, from my perspective anyway, I thought this one was, a little bit more interesting, because the problem was when you have these discretionary funds, or you can increase a financial aid offer, the question was, and maybe you've all asked it before as well, do you increase the amount of funding you're offering uniformly for everybody, or do you increase it significantly for some? So do you cover all need for some, or do you cover some need for all? And the solution that they had come across, and I think that this one did end up coming through the support side, and so we helped out a little bit, and what we came about was a plan to identify where that additional aid money was having the largest impact, which you can actually figure out through predictive modeling. And so here again, a visual aid might help out. And I think personally, I hope that this comes across as neatly as I think this demonstrates the issue, but along the bottom axis, just sort of stepping through this, along the bottom axis, you'll see that there is a financial aid offer amount. And wherever this point actually resides, because everybody's tuition is different, this isn't really important. The important piece is that this is a step size of $1,000, and this is also a step size of $1,000. So notice that if you're looking at someone who isn't already receiving a significant amount of financial aid, but has potentially a significant amount of need or something along those lines, that $1,000 is going to net you a significant increase in their enrollment likelihood. Whereas if you were to assign that same $1,000 further along the spectrum and say, okay, well, that's going to get us an extra 2% likelihood, clearly the larger impact that money might have is down here. And so if you're trying to maximize not just the institutional benefit from the additional aid money, but also the student benefit, if you're trying to really meet people's need and you're trying to actually speak to people who are who need this money, then you can look at it this way as well. So hopefully that makes sense to everybody. And pulling up this recap, this overview of what we've talked about so far, I'd like to personally emphasize that this is hardly the extent of all possibilities. These are the ones that we've covered today. But as I turn it over, John is going to actually be walking us through one of these, so I'll yield the floor here. But do keep in mind, if you have any questions, we would love to answer those. And so as he starts to move forward, be sure to ask those.
Thank you, James. And yeah, as we saw with the challenges, there are a number of those, and as James mentioned, a number of ways to solve those problems as well. So covering sort of three techniques today, and what we'll actually look at is through our software, creating an analysis around binning like applicants and seeing what is our expected expenditure, how many students are we going to enroll, and how much money are we going to spend in that process, looking at different increases in scholarship aid. And so for that, I'll actually jump into the software, and we'll start out in Vera Construct, which, as James mentioned, is our data preparation and reporting tool. And this is what allows you to access data from any of those different data locations that you have, whether it's your student information system, your prospect management tools, Excel files, CSVs, whatever sort of data you're working with, you can access right here in Vera Construct and pull all of it together to create these historical data sets and these analyses. And starting out, I'm just going to open up kind of an idea of what the data preparation looks like. We won't spend too much time here. We'll jump right into the predictive modeling, but just to give you an idea of sort of the extent that we go to actually pull in this data. We saw that there were a lot of challenges, a lot of that around actually accessing the data. And what Vera Construct allows you to do is pull in your Banner student information system or any other student information system, connect to it directly, pulling in financial aid awards, registration information, applicant information, as well as connecting to other sources. Maybe you have your applicants stored in a Salesforce database or in Slate. You can access those as well, merge all of that data together, clean it up, and then prepare it for this analysis. And that is really a big part of this. So being able to accurately identify this information, clean it up, so that you have it prepared for this modeling process. And so this actually goes through and does that. If you work with Banner, some of these tables may look similar to you. This is kind of the piece that we're focusing on, this financial aid information. But because we saw that as scholarship aid increases, we're seeing a decrease in enrollment, we saw that there are underlying factors. So we have other pieces that are looking at things like academic scores, academic ranks, high school GPA, and so on. And with this process, I now have this automated where I can run this for any term, and I can just choose to pull directly from our database, prepare this file. I could build a 3-year, maybe I need to go back a little bit further and build a 5-year analysis file. I can now do that automatically. And that's where we jump into the actual predictive modeling. So once we have this data set nice and clean, we can then load it into Vera Predict and take a look at how this impact or how this increase in scholarship aid is impacting our enrollment. And so with that, I'll open up Vera Predict here. And again, just like Vera Construct, you can connect to really all of the same data sources. In this case, though, I've just loaded in that analysis file. And then I can go through and in this first screen here, just see what information I have available. These are often important fields when looking at enrollment modeling, things like how far in advance did the student apply, how many miles do they live from campus, their need, their estimated family contribution, etc. But what we're really interested in is how does our scholarship aid field relate to enrollment? And so to see that, we can jump right to visualize, and I can look at enrolled as my Y variable, and then I can take a look at my X field as scholarship aid. And here again, and I'll make this just a little bit easier to see, we see that same relationship we saw before. So students that are offered $10,000 plus dollars, we're seeing lower yield. And so we see this negative relationship with scholarship aid. But right now we're looking at all students, all of our admitted applicants over the past 3 years. And so rather than doing that, we can look at like students. And in this case, in the example in the slides, we looked at high school GPA. In this case, we have actually an academic score, which is based off of high school GPA and test scores. You may have something similar. If not, certainly you can use really any sort of academic indicator. But here we're going to go in and set a filter right in the data set. We're going to look at that academic score. And I'm going to set this to similar students. In this case, I'm actually just going to choose 2 scores. It's a scale of 0 to 30. So we're going to kind of go right in the middle here. And we're going to see what sort of impact this has once we look at this new data set. And so I can add this in, I can save here, and now we see this kind of flip. So this is what we're expecting. We're expecting an increase in aid to increase our enrollment. So we're looking for this positive relationship because we want to see if we do offer students an extra $1,000, what is that going to do to their enrollment? Are we going to see a higher enrolling class? And if so, how much? And then how much money will that cost? And so this is really key in any of your analyses, being able to kind of adjust the cohorts that you're looking at, the actual data that you're analyzing, and being able to identify the real underlying factors when it comes to the relationships that you're seeing. And we can quickly do that here. Another nice feature right in this Visualize tab is being able to check to see if this is significant. So I can just check this box here, and if this stays in as a related variable, I know it's statistically significant at this level. Additionally, this filters down all of the other fields, so everything in here is statistically related, and so these are some of my other key indicators of enrollment. But for the sake of time here, there's plenty of other things that we can go through, but we'll just actually build this model. So I'll go right to model. And what we can do, and what some people choose to do, is actually bring in and sort of force in financial aid variables. And so you can do that. You can build a model based around your own selections. But in this case, and generally what most of our customers do, is just let Predict build the model automatically for us. And I can just select this option here, build automatically, and it builds the best model it can based on the data that we provided. And maybe I want to include some more information within the data set, but overall this model looks pretty good. And one way to sort of judge that is this decile analysis here on the right. And what this does, it breaks our file into 10 equal bins. So 10% of all of our applicants are in each column. In the first column are the applicants that are expected to have the highest yield. They're the ones the model said have the highest probability of enrollment based on all of these different factors we see in this window here. And they in fact do. So they have an enrollment up around 43%. And then we see kind of a staircase from there, a couple ups and downs along the way, not a perfect staircase, but this is really what we want to see, is that we're correctly identifying our most likely enrollees in these top deciles, and then our least likely enrollees in these bottom deciles. There's a lot of information here, so we won't go through too much of it, but one nice thing is at the very bottom of this variable statistics window, we can actually see what's impacting enrollment the most. So campus visits is by far our top contributing factor. And then we see their need score, how many days in advance they applied, and then scholarship aid comes in. So it's not our biggest influencer when it comes to enrollment likelihood, but now we can see what sort of impact that has. And if we do increase scholarship for certain students or our entire population, what does that do to our yield? And so for that, we're going to actually save this. We'll call this our enrollment model with financial aid. and we'll memorize that. I can choose to save this model. So I'm just going to save it right to my desktop. And then beyond that, something that we don't often show all that much in these webinars here, but one thing that is really neat, especially when it comes to scholarship aid and looking at financial aid modeling, is looking at this what if analysis. And so I can go in here and I can see some general information about a student and then what their anticipated enrollment yield is, which for this student in particular is very low. But if we were to see if a student visits campus twice, they have a 40% enrollment yield with these other characteristics. But then beyond that, if we were to increase scholarship aid by $1,000, what does that do? So we can see the actual impact that this variable has and the increase in scholarship may have on a potential applicant. But rather than do this case by case, if we wanted to see the actual individual students, the individual applicants that have currently applied for the upcoming term and what their probability of enrollment is, we can apply this model back in Vera Construct and get that number, get the probability of enrollment for each individual student. And so I'll head back there. We will open up this other job that's just pointing to the data preparation process we've already designed. And then I can, in this job here, just call on that scoring model that we just saved. So I can open that up right here. And this incorporates everything here for me. And now I can just go ahead and run this job. And we'll see it prompt me here for whether or not I want to increase scholarship. So if we want to leave the offers as they are right now, I can choose to just run with a $0 increase. And this actually creates a list of scored applicants, as well as a little report here to give me some more information. And here I can go in and view this data. I can see all of my student records, and then I can see their probability of enrollment. And I can sort this here now and look at those with a 99% probability of enrollment and down from there. And so this is the information that James was talking about in some of their sort of allocations of discretionary funds, is being able to identify those students with a high propensity to enroll. Maybe you also look at a high propensity to be successful, a high success likelihood as well, and you allocate the money for those students. In this case, in the example that we're kind of working through here, it was really to see, can we increase yield overall? And if so, where are we going to be impacting students the most with an increase in spending? And so in this same analysis or the same workflow, I have this report that runs and shows me with a $0 increase, with offers the way they are right now, we're seeing about a 10% yield or closer to 11% yield for all applicants. I can see the predicted enrollment of 339 students. And then I see average aid, total aid, and then the predicted expenditure. How much are we expecting to actually pay in this scholarship? And from there, we can actually go back in and we can run this job again. And we can say, well, what happens now if we increase by $500? And so it automatically runs once more. I can open this up and I can see with a $500 increase, we're up to a 12.3% yield, maybe 30 or so more students. But we're seeing more money or a larger expenditure as well. And we can run this for different scenarios. But again, one of the nice things here is we can call on this process to run over and over and not have to kind of flip back and forth. So I set up a report that looks at a few different iterations of that job and what sort of impact it's going to have on this incoming class. And so here I can run this report looking at a $0 increase or original offer amount, a $500 increase, and then a $1,000 increase. And if I view this report here, we can now see for each individual college, what is the expected yield? What is the average scholarship aid? What is the predicted total accepted aid? And then for the different increases, we're looking at 11.3% to a 12.6% to a 14.3%. So from $0 to 1,000, we're looking at about 100 more students that we're going to end up enrolling. But also we're looking at $1.4 million more in expenditure. And is that something that we have within our budget? And we can see that a little bit better down here as well. And these are reports that you can send out or automate. So you could schedule this to run. You could set this up to email or distribute automatically. And another option is to actually publish this to Viewer Bridge, which we'll quickly jump into just to show you that real quick. But again, we're going to be opening up to questions here in a moment. So if you have those, please feel free to type those in. But with this report, when this job runs, I also have this set to publish to Viewer Bridge. And so Viewer Bridge is a cloud-based reporting platform. So instead of having to email out those reports, instead of having to have people find it on the labyrinth of a network, then you can publish it directly here. Share this with any of the individuals in your organization. So if I wanted to share this with James, I can go through and give him access. And then with this report, whenever that job runs, this is automatically going to update. So I don't have to worry about version control, whether people are looking at the most recent number of applicants or the recent projections. This is always just going to refresh. They'll have access to this data as soon as it becomes available. And so this is just a convenient way to sort of create a conversation around the data. So you can comment on this information. You can share notes about it. What does this data mean? How are we getting these probabilities or these projections? So you can really create a more sort of data-driven culture, a larger discussion about how this information is found and how it should be used. And that I know is a little bit of a whirlwind tour, but that's mostly everything I had to show. So if there are specific questions on the process that you just saw, or just generally about financial aid modeling, we're happy to answer those now.
Yes, indeed. And I want to start off by thanking John for sharing all of that with us. It's really impressive what can be done when you pull all of this information together. And you know, as would be happy to talk about as well, the actual mechanics of it are really quite simple. And so we'll move over into questions here. Some have been coming in throughout, so stick with us. The first question that had come in is, what if my financial aid office prefers not to share data for analytical purposes? So John, do you mind speaking to that?
Yeah, definitely. And it is something that we see occasionally. I would say the majority of our customers do have access to it. But if it's not something that you have access to, as we saw within the analysis here, we could even go in and exclude scholarship aid and run a new model. You can still build models without financial aid information. And then, as we saw in some other use cases, use the probability of enrollment as an indicator or an identifier for those students that may be more receptive to a larger offer amount. So even if you don't have direct access or access to the data at all, then you can incorporate other variables that you most likely can access into a model and use that information to inform your financial aid packaging.
Yeah, well put. I personally have nothing to add to that. So hopefully that answers the question for that person. We did have another question here. This one is, in the offers based on enrollment likelihood case, does it work better to have all federal and state grant aid loaded into the system before you do the likelihood to enroll analysis? And I can actually field this one. So this one came in. The baseline for that project, so I think that you're referring to the one back on in the PowerPoint, I think it was the second prompt that we had was allocating offers, typically discretionary, but you know, otherwise if money comes in that allows you to address more need, to do that not as a factor on which to predict their likelihood of enrollment, but to use their likelihood of enrollment to allocate the funds. And so in that case, then yes, it's whatever financial aid is already being offered. If that's going to enter the model, then you would maybe want to have that in your predictive model. But John, I guess the question worked out the timing there, because John had just pointed out that if you don't have the financial aid available, then you know, you can either use your standard need aid in the model and then explore the effects of your discretionary aid after the fact. So it can work either way, but it's best obviously to factor in any other federal funds that they have available already. So Some other questions, actually a lot, so yeah, keep them coming. Could I use this to look at my net tuition revenue for the institution? So John, I'll turn that one to you.
And yes, you certainly can. So looking at their probability of enrollment gives you an indication of some net tuition revenue there. But looking sort of longer term, if you include a probability of success or retention, whatever that success measure is for you, you can incorporate that as well. So overall, you can have a larger picture of what is the expected continuing enrollment, what is the expected net tuition revenue for the next full year, and sort of work from there.
Awesome. Yeah, and I'm seeing that come up a lot as far as even other presentations that are being offered or at conferences. A lot of people are talking about looking at the overall institution spend model. So a hot topic these days. Let's see. And so let's see, a couple other questions. Oh yeah, okay. So here, are some of those variables calculated, or is that how they are pulled out of the student information system? And for context, I'm assuming they're referring to the models used in the analysis you showed, John?
Yeah, and in this case, what we actually filtered on, the academic score, is a calculated field. We actually have a previous webinar by Dan Brzezinski at Fairfield University who talks a little bit about that and incorporating a academic indicator based on, I think his was high school GPA test scores, and maybe there was some even like interview element incorporated there. But you can calculate those yourselves. If it's already in the student information system, you can certainly pull directly from that. But as we talked about, looking at things like EFC as a percentage of tuition rather than EFC overall. So how does that cover the cost to attend the institution? And so looking at sort of calculating some of these measures based on sort of controlling for different changes or different relationships throughout the years. And most of that's done within Vera Construct. So in this job here, we're going through and calculating new variables. We're cleaning up fields. So a lot of that's done within the data preparation process, pulling directly from the student information system.
Right. And I'd like to make a couple of plugs of my own as on the tail of that question, being that the presentation is also maybe focused at some people just getting started with this process. You might begin with only the things that your student information system currently provides, and then iterate your way towards having dozens of calculated fields. And so whatever you have right now is good enough to start the process, but then you may expand that. And we also, the second bit there, we also provide as a resource through training, we provide lists of suggested variables, things that you might consider incorporating into your data sets. So it's a great question, and regardless of where you're able to go with it, there are possibilities. So let's see. This one actually, again, these are working out very well for us today. This one is maybe speaking more towards the support side, but in working with customers, John, do you find any specific variables consistently predictive of enrollment and or retention?
Yeah, as James mentioned, we actually provide a suggested list of variables that we've sort of built over the years, a library of fields that we consistently see as being significant. So it's something we're certainly willing to share. So if you are interested, you can reach out to us personally, and I can actually put our emails up here. But I think some of the more interesting things, so things like days between application and term start, we used to have FAFSA choice flags available to us. So you could see, are you the first choice for this applicant? And that has sort of gone away, but now we have a new indicator that sort of takes that place, which is days between application and term start, generally showing how invested in the institution they are. So that is what I find most interesting about that, is often related in both enrollment and retention. So it usually comes in actually to like a first year retention model as well as an enrollment model. And sometimes it even has the inverse relationship. Students that apply further out sometimes have lower yield than those that are applying last minute. whereas retention, students that apply further out have higher retention rates. So kind of interesting to look at, but there's a lot of like new data out there, things that we generally couldn't access before. So how many contacts has the student had before even applying, or after they applied? Are they logging into some portal? We had one institution that found if a student submitted an application and they were constantly checking that application status, logging into this portal, they could then, from that, could then identify how likely they were to enroll, and it was one of their top contributing factors. So a lot of that is really interesting, but if you are interested in the list of variables, we're happy to send that out as well.
I had not heard that scenario before, so that's pretty cool. So thank you, John, for that answer, and hopefully that answered the question for that attendee. We have, I think, just a couple of more questions. We want to be respectful of everybody's time. This next question, John, is about modeling in Vera Predict. What are the different types of models that Vera could build?
So within Vera Predict, we're looking at logistic regression and ordinary least squares, as well as decision trees. And one of the nice things about that is when you incorporate a data set and then choose what you're looking to predict, which in this case was just a binary outcome of whether or not they enrolled, it will automatically determine that for you. So it chooses that regression type for you. And then beyond that, you still have control over this. You can go in and modify that as well. And then within Vera Construct, there's also some other algorithms that are available. So if you want to, or if you are familiar with R or any other scripting language, you can incorporate that right into the process. There are some that are built in directly into the script here. So you can go in and create neural networks and decision trees, things like that, right in Vera Construct as well. But within Predict, it'll be those three options.
Great. Thank you, John. And we do have one last question. I sent out a request for clarification, but at the moment, the question stands, should I be more worried if my data is not correlated? And hopefully I'm interpreting it correctly here. But one of the things that I'd like to personally comment on is just in the same way that John has been pointing out your relationship between financial aid and enrollment, or any other student success or on-time completion, in the same way that those relationships might be impacted by confounding variables. It's possible that if your financial aid has no relationship to enrollment or with student success, maybe it's for the same reasons that it's tied up in other factors. And so the same sorts of questions that John's been pointing out, these are things that you might want to be asking even in that case. And with that, we have fielded all of the questions presently, but we do hope that you'll consider sending more questions our way after the session here, and stay in touch. This recording will be available, and for more information, check out our website at www.rapidinsight.com. Thank you very much for your time today, and we hope we'll get to see you again.